So now we're going to solve rational inequalities. And again, rational, once you see that word, you know it means fractions. So we're going to solve inequalities that happen to have fractions in them, and they're fractions specifically where you have variables in the denominator. So again, you're going to get the equation to where it's greater than or less than 0. At that point, you're going to end up combining the terms so that there is just one fraction. Okay, we'll talk about that. So the single fraction equals 0. Once you get to that, you're going to make the numerator equal to 0 and find that variable value. You're going to make the denominator equal to 0, find that variable value, and then you're going to test points to figure out where the solution ranges are. So it sounds like a lot. It's really not too bad. Okay, so again, let's look at this, and what we see here is that we have a rational inequality. We've got 5 over x plus 4, and it's greater than or equal to 1. So first of all, it's down to a single fraction, so we saved that step, right? But the first step is to get it greater than or equal to 0. So I'm going to have to subtract 1 from both sides. So I'm going to have to get minus 1 is greater than or equal to 0, like that. Now I'm going to have to get that left side to be one fraction. So basically, I'm going to have to get the denominator to be x plus 4. So that means I'm going to kind of have to multiply, right, by x plus 4 here. So I know that this is already x plus 4, so it's going to stay the same, right? And then this one, it's going to be 1 times x plus 4, and then it's going to be all over x plus 4. Okay, or x plus 4, sorry, there. And then again, that's greater than or equal to 0. So what I'm going to get here in my numerator is 5 minus x minus 4 all over x plus 4. And this is going to simplify to 1 minus x over x plus 4. Again, is greater than or equal to 0, right? So now, notice that what you have is this inequality at the top, or not inequality, it's expression at the top and an expression at the bottom. So we're going to make the top expression equal to 0, and we're going to figure out what does x equal. It equals 1. And we're going to make the bottom expression equal to 0, and we're going to figure out what x makes that happen. So now we have these two x values that we've been able to identify, the one in the numerator and the one in the denominator. And so we're going to separate this. We're going to do negative 4 here. We're going to do 1 here. And again, notice we're kind of breaking this up into these 3 sections. 0 falls here in the center section, right? And so I'm going to try 0. I'm going to go to the original equation, and I'm going to try 0. So I'm going to substitute 0 in for x, and I'm going to get 5 over 4 is greater than or equal to 1. And that's a true statement, which means that 0 is a solution, which means that this one and this one are not. Okay, so again, this is an equal to thing. So I know it's going to be a solid circle this way and a solid circle this way. The only side to this and the only issue to this is that, remember that my denominator can never equal 0, right? Because again, we're still talking about a rational expression, and we know that when the denominator equals 0, it's an undefined statement, so it can't have it. So what value makes the denominator equal to 0? Well, in this case, it's 4, right? So 4 can, or negative 4 rather, right? So even though I got this solution here that it was negative 4, it can't actually equal negative 4, because in this particular problem, negative 4 is kind of extraneous, right? So what I have to do is I have to just change it here to where negative 4 is an open circle. So in other words, it starts at negative 4 but doesn't include it, okay? And so my solutions here, if I was to list it out, right, in interval notation, it's going to be negative 4 with the parentheses there, and it's going to end at 1 with a bracket. And so this is the solution of this answer, okay? All the values between negative 4, not inclusive, and 1 inclusive. So again, let's go to the next problem. And because this problem doesn't have an equal sign, okay, we don't have a problem about, you'll see that we won't have the problem with that bracket or whatever, the denominator. You'll see what I mean. Again here, it's set equal to 0 already, and actually it's already one fraction. So this one just requires me to take the numerator and make it equal to 0, so x is -1. And then take the denominator and make it equal to 0, and x is 4. So I go over to my, my graph, and I create my little partitions, right? I've got -1 and +4. And again, 0 is here. So I'm ready to kind of plug in and try 0. So this is 0, this is 0. And I'm going to get -1/4 on the left is greater than 0. And that's false. So 0 is not a solution, which means then this side is and this side is. So notice this is greater than, not a greater than or equal to. So I'm going to have an open circle here and go this way, and an open circle here and go that way. And so notice again, I know that my denominator, x cannot be 4 for me. If x is 4, my denominator is 0. But notice that I have an open circle at 4, so it's not even an issue. If it was a closed circle, it would be a problem. So when you have to be careful with the denominator is when you have an equal sign in your inequality. So let me write this as in interval notation. I'm going to go from -infinity to -1, parentheses in both, union, and then, sorry, I don't know why I do it like that. It's like that. And then I'm going to have 4 to +infinity, and again, parentheses for both. So we keep going again here, and we have two different problems here. So let's start with the one on the left. Again, it has to equal 0 or be less than or greater than 0 rather. So I'm going to have 2x minus 1 over 3x plus 4 minus 4 is going to be less than 0. And so now, again, I know my denominator is going to have to be 3x plus 4 here, so I'm going to have to multiply this by 3x plus 4. Okay, so I'm going to get 2x minus 1 minus 4 times 3x plus 4 all over 3x plus 4. And I'm going to have to distribute. So I'm going to get 2x minus 1 minus 12x minus 16 all over 3x plus 4. And again, I'll combine my like terms up at the top, and I'm going to get negative 10x minus 17 all over 3x plus 4 is less than 0. Okay, and so again, I have it in the right form now. I'm ready now to set my numerator equal to 0. And so negative 10x equals 17, and x equals 17 over 10, or negative 10, right? So I'm able to get this answer, and then I get the denominator 3x plus 4 equals 0, 3x equals negative 4, so x equals negative 4/3. So these are my little dividers in my graph, right? So again, negative 17 over 10 is going to be greater or less, right? So this is going to be negative 17 over 10. This is like 1.7. And this here is like a negative 1.3. So it's going to look like this. Here's negative infinity. Here's positive infinity. Again, these are like little partitions. And I got to see where 0 falls. And 0 falls over here. So again, I'm going to go back to my original fraction at the very top. And I'm going to swap out 0 here. So if I put this, make this 0 and make this 0, it goes away. So negative 1/4 is less than 4. And that's true. So 0 makes the statement true. So if 0 makes the statement true, I know this is a solution, this one's not, and this one is. Again, my inequality symbol is a less than, so I know that I'm going to have an open circle this way and an open circle that goes that way. And so in interval notation, my solution is going to be negative infinity to negative 17 over 10. Parentheses, union, negative 4/3 to positive infinity, parentheses. So it's, it's not too terribly hard. It's just, again, it's work, right? It's not easy. And then we go to this next one. Again, we're back in the same boat. We have 6 over 5 minus 3x minus 2 is going to be less than or equal to 0. Again, I need this denominator here to be 5 minus 3x, so I'm going to have to multiply the numerator by that 5 minus 3x. So let's distribute 6 minus 2 times 5 minus 3x all over 5 minus 3x. And again, it's going to be 6 minus 10 plus 6x over 5 minus 3x less than or equal to 0. And again, combine our like terms. So minus 4 plus 6x over 5 minus 3x less than or equal to 0. So now I'm going to make my numerator equal to 0. And I'm going to get 6x equals 4, x equals 4 6, which is 2/3. And I'm going to make my denominator equal to 0. So negative 3x equals negative 5, and x equals negative 5 over negative 3, which is 5/3. Okay? And so now I go to my lines here, and my number line, and I'm going to identify 2/3 here. So 2/3, and here is 5/3, and I know that 0 is over here. And again, I've kind of broken this into my little partitions, right? It's my sections. So I got to figure out which sections work. So again, I'm going to plug in 0. I'm going to go back up here to the original problem, and I'm going to get 6 over 5 is less than or equal to 2. So 6 over 5 is 1 1/5. And yes, that's less than or equal to 2. So it's true, which means 0 is one of the solutions. So these are my sections. This is a less than or equal to, so I know that I'm going to have, I should have, right, a filled in circle here, and it should go this way, and I should have a filled in circle here and go this way. Now you might say, well, why did you not fill in your circle? Well, again, I always have to look at my denominator, and in this particular case, I'm making my denominator equal to 0. Well, guess what? My denominator cannot equal 0. So in this case, if I bubbled in the 5/3, if I made it solid, that value would make my denominator 0, and I can't have it. And so I have to open this circle. So you always have to look at the denominator, okay, or the value of the denominator. Okay, that's the one that matters. The numerator is always going to be solid or whatever. That's not going to be affected. So here I'm going to have negative infinity to 2/3, bracket, parentheses, union, parentheses, 5/3 to infinity. Okay, and so again, this is the tricky part, is remembering that this has to be an open circle when we're talking about an equal sign. Here we have just a few more examples of it. We're going to continue to work this way. Again, we have to make it equal to 0 first of all, or greater than or equal to 0. So we're going to do minus 5 over 3x plus 2 minus 5 over x is greater than or equal to 0. Now I have to get this left side, again, to have this common denominator. So my denominator is going to have to be x over 3x plus 2. Which means I'm going to have to multiply my first term, negative 5, by x, and I'm going to have to multiply the second term, negative 5, by 3x plus 2. So again, distribute minus 5x minus 15x minus 10 all over x times 3x plus 2. And combine my like terms, minus 20x minus 10 over x times 3x plus 2, greater than or equal to 0. And again, now I'm going to make my numerator, minus 20x minus 10, equal to 0, and my denominator, x times 3x plus 2, equals 0. So up here, I'm going to factor out my GCF, or I don't even have to do that. I'm just going to solve. So minus 20x equals 10, divide both sides by minus 20, and I get minus 1/2. So there's one solution. And then x equals 0, that's a second solution, and 3x plus 2 equals 0, so 3x is negative 2, and x is negative 2/3. So I have 3 solutions or 3 partitions to my solution set here, right? So I've got negative 2/3, I've got negative 1/2, and I have actual 0. So now this is what I was telling you, I'm kind of stuck here because I can't use 0, right? So what I'm going to do is I'm going to use the section that includes 1, right? 1 is in this last section, I'm going to use that. So I'm going to come back over to the original problem and replace x for 1. So it's going to be negative 5 over 3 plus 2 is 5, is greater than or equal to 5 over 1. So we've got here negative 1 is greater than or equal to 5, and I know that that's false. So I know that the area that includes the 1 is false, which means this is true, this is false, and this is true. And so now I know my solutions. This is a greater than or equal to, so if I'm drawing it out, I know it's going to be a filled in circle up and over. It's going to be a filled in circle up and over, and a filled in circle up and back this way. But remember that at your denominators, you have to look at it, but because it's greater than or equal to, remember that your denominator cannot be equal to certain ones. Whatever ones are in the denominator, it can't actually equal those specific numbers. So at x equals 0 and at x equals negative 2/3, we have to do an open circle. We can't do a closed circle because that would make those in undefined. So I have to go back, and here in this problem and in this problem, I have to put an open circle at these numbers, okay? The value of the numerator, this came from the numerator portion of this problem. That can be anything, and that can be a filled in circle. So now when I go to do my, remember this is negative infinity and positive infinity, so when I go to do my interval notation, it's going to be negative infinity to negative 2/3, parentheses, union, and I'm going to do negative 1/2 to 0. It's going to include the negative 1/2 but not include the 0. And so that is my solution. So a lot to remember in these. Again, several weeks ago we added and did rational expressions, so the part of the common denominator and all that should be pretty easy at this point. The hard part is learning the new skills attached to that. So again, here we have 1 over x minus 3. And we're going to do minus 3 over 2x plus 1 is less than or equal to 0. Now we're going to make these a common denominator, right? And so we know that the denominator we're going to have to get is going to have to include x minus 3 and 2x plus 1. So I've got to multiply each term by that, right? So the 1 over here is going to be multiplied by the 2x plus 1. And the minus 3 is going to be multiplied by the x minus 3. And so again, I have to distribute and combine like terms. So 2x plus 1 minus 3x plus 9 all over, these can stay separate, is less than or equal to 0. Combine my like terms, I get minus x plus 10, x minus 3, 2x plus 1 is less than or equal to 0. So now, again, I'm going to set my numerator equal to 0, and I'm going to figure out what x equals. So x is 10, so that's one solution, right? And then I'm going to set my denominators equal to 0, or the factors in my denominator equal to 0, okay? So this one's going to be x equals 3, and this one here is going to be 2x equals negative 1, x equals negative 1/2. Now, these two here are related to the denominator, and notice that this is a less than or equal. So I'm going to put on my graph, I know I'm going to need an open circle at these two, and this one here will have the closed circle. So I'm going to come over here to my graph, and I'm going to put these in order. Here's minus 10, or minus 1/2 rather, positive 3, and positive 10. And I see that 0 is over here. So I got to find which are my solution sections. I'm going to come back up, and I'm going to make these 0, and I'm going to get 1 over negative 3. So negative 1/3 is less than or equal to 3 over 1. So is negative a third less than or equal to 3? Yes, that's true. So 0 is a solution, which means this is a solution, which means to the left is not, to the right is not, and this one way over here is. So now I'm ready to do my graphing the solutions, right? So I know I'm going to have a closed circle at 10, an open circle at 3, and an open circle at negative a half. And again, my solution area is to the right of negative a half, to the left of 3, and it's to the right of 10. And so that would be my graph. And now how do I write that in interval notation? Well, negative a half with a parentheses, over to 3, also with a parentheses, union, and then I'm going to have a bracket at 10 because it includes 10, and it goes to infinity with a parentheses. And so again, there's my solution set. So here's the graph of it, and this is interval notation. And again, we just have to be very, very careful. And worrying about the denominator, open and closed circle, comes with when the inequality has an equal sign embedded in it. Last but not least, we come to the very last problem. Again, more examples of the same. We start out, we get 2x minus 7 over x minus 5 minus 3 is less than or equal to 0. And then now I know if I want my denominator to be x minus 5, I'm going to have to multiply the numerator by that. So I'm going to get 2x minus 7 minus 3x plus 15 all over x minus 5 less than or equal to 0. Combine my like terms, minus x plus 8 over x minus 5 is less than or equal to 0. So again, I'm going to solve my numerator equal to 0. Negative x equals negative 8, so x is 8. So one solution. My denominator, x minus 5 is 0, so x is 5. And again, my denominator, this again, I know that yes, it equals 0, but I know that because it's an equal sign there, this has to be an open circle, and this one is going to be closed. So again, now I've kind of thought about it ahead of time this time. And so my solutions are 5 and 8. I know I'm going to have this open circle at 5. I know I'm going to have this closed circle at 8. But now I got to figure out what's going to happen, right? What direction? Well, 0 is over here. So I'm going to plug in 0. If I plug in 0, it's just negative 7 over negative 5. So that's 7/5 is less than or equal to 3. 7/5 is 1 2/5. So yes, it is less than 3. And it's a true statement. So 0 is a solution, the middle is not, and the right side would be. And so I know it's going to be this open circle and to the left, and this closed circle and to the right. So how do I, remember this is negative infinity, this is infinity. So how do I write it? It's going to be negative infinity to 5, parentheses, union, 8 is included, to positive infinity, parentheses. Again, we don't care what the denominator is. It can be equal to 0. We don't care what the numerator is. It can be equal to 0. It's the denominator where we have to be very, very careful. That's it.